Hi everyone, welcome back to Java Full Stack Flow. Today let's understand another important Java interview question is what is the factory design pattern? This is the one of the most commonly used creational design patterns. Let's understand it step by step with a real-time example. What is factory design pattern? Factory design pattern is a creational design pattern that provides an interface for creating objects in a superclass but allows subclasses to alter the type of objects that will be created. Means instead of creating objects directly using the new keyword, we ask a factory class to create the object for us. The client simply requests an object and the factory returns the appropriate implementation. In simple words, it hides the object creation logic from the client and returns the appropriate object based on input or conditions. Means, for example, in a payment application, if the user selects UPI, the factory creates a UPI payment object. If the user selects credit card, it creates a credit card payment object. The client doesn't need to know how these objects are created. Examples are payment gateway, notification, logger. These are common real-time examples where factory is used. Based on user's choice or configuration, the factory returns the required implementation. Next, why do we need factory pattern? First point is removes object creation logic from client code. This means the client doesn't create an object directly using the new keyword. Instead of it, the client simply asks the factory for an object and the factory handles the object creation. Next, second point is reduces the coupling between client and concrete classes. Coupling means dependency. Without a factory, the client directly depends on classes like credit card payment or UPI payment. With a factory, the client only depends on the payment interface and the factory. This makes the application loosely coupled. Next, third point is easy to add new implementations. Means suppose tomorrow the business wants to support wallet payments. We simply create a new wallet payment class and update the factory. The client code remains the same. That's why adding new features becomes easy. Next, fourth point is improves code maintainability. Since all object creation logic is centralized in one factory class, maintaining the application becomes much easier. If object creation changes, we update only the factory instead of modifying many client classes. Next, fifth point is centralizes object creation logic in one place. Means all object creation happens inside the factory class. This given us a single place to manage and control how objects are created, making the code cleaner and more organized. Next, sixth point is follows open closed principle. Open closed principle means the application should be open for a extension but closed for modification. Means we can add new payment types by creating new classes and updating the factory without changing the existing client code. Now that we understand why we need the factory pattern, let's see how it actually works with a simple flow diagram. How does it work? Step 1 is client request an object from the factory. Means first the client doesn't create an object directly. Instead of it, it sends a request to the factory class. For example, if the user selects UPI as the payment method, the client asks the factory to provide a UPI payment object. Step 2 is factory creates the appropriate object based on input. Here the factory checks input received from the client. If the input is credit card, it creates a credit card payment object. If it's UPI, it creates a UPI payment object. If it's net banking, it creates a net banking payment object. The factory decides which object is to create. Next, step 3 is factory returns the created object to the client. Finally, the factory class returns the created object back to the client. The client simply uses that object to perform the payment. So the complete flow is simple. The client sends a request to the factory checks the payment type, creates the appropriate payment object and returns it to the client. This keeps the client code clean because all object creation logic handled inside the factory class. Now that we understand the flow, let's look at the simple code example. Creates a payment interface. The first step is create a common payment interface. This interface contains a common method. For example, pay method. Every payment type will implement this interface. Next, create concrete classes. Credit card payment, UPI payment and net banking payment classes. All these three classes implement the payment interface and provided their own implementation to the pay method. Next, create a payment factory class. Now we create the most important class, the payment factory. This class is responsible for creating the required payment object instead of creating object in the client code. We move that responsibility to the factory. Next, example, client calls payment factory.getPayment of UPI. The factory checks the input. Since the input is UPI, it creates UPI payment object and it returns to the client. So here the client never uses the new keyword to create a payment object. It simply requests an object from the factory and the factory decides which implementation to create and returns. This makes the code clean, loosely coupled and easier to maintain. Next, in interview you can answer like this. Factory design pattern is a creational design pattern that provides an interface for creating objects but allows subclasses to decide which class to instantiate. It hides the object creation logic from the client and returns the appropriate object based on input or conditions. This reduces coupling between client and concrete classes, improves maintainability and makes the application easy to extend. Some real-time examples are payment gateway, logger and notification. That's all about factory design pattern. If you found this video is helpful, please subscribe my YouTube channel and follow me on Instagram for more real-time Java full stack interview questions. Thank you.